to calculate seasonal indices, we've got to do two things. First thing we've got to do is we've got to calculate the seasonal index of each of these points. The way to do that is it's the actual figure divided by the yearly average. So we're going to have to calculate the yearly average, and the way to do that is we're going to add up all of the 2022 data and then divide it by 4, which is 68.75. And then we're going to repeat that for the other years too. We're going to divide each individual cell by the yearly average. So we're going to have 200 divided by 68.75, 50 divided by 68.75, etc. So that's for 2022. And then we're going to do the same thing for 2023 and for 2024. So once we've calculated those seasonal indices in our seasonal indice table, then we've got to calculate the average quarterly seasonal index. The way we do that is we're just going to add up all of the values for summer for each year and divide it by 3, or we're going to divide it by the number of years that there are. So that ends up being 2.83, and then we're going to do that same thing for every season. So these are our values here for the average quarterly seasonal indices. Now we're going to deseasonalize the values. So the way to deseasonalize the values, and this is the second formula, you don't get on the formula sheet, so you're going to have to memorize this formula. But to deseasonalize the values, we've got to do the actual figure divided by the seasonal index that we just calculated above. So we need to divide all of these values by their corresponding seasonal indice. So when we do that, we get these values here, and these are considered the deseasonalized values. They're also considered as the seasonally adjusted values. You can call them either, but they're deseasonalized. So now we've got the actual figures, so what we started with, and the deseasonalized values. What you'll notice is that the deseasonalized values are a lot closer together, which means that the original data set has been smoothed. I've got a time series graph here that's got the actual figures and the deseasonalized figures, and you can clearly see that the deseasonalized figures have smoothed out the graph. So there are 3 smoothing techniques in Year 12 General Maths Unit 3. Those are mean smoothing, median smoothing, and deseasonalizing data. At the moment, we're doing deseasonalizing data. So just a few other things to note. So this is my seasonal index table from before. It's really important to note that for each year level, when you add up the seasonal indices, it should add to 4, or due to rounding, it could be 4.01 or 3.99. And another thing to notice is that the seasonal index, if that equals 1, it means that it's an average for that year. When we have a seasonal index of 1.5, that means that it's 50% above average. And if we have a seasonal index of 0.8, that would mean that it's 20% below average, etc. So just to summarize, to deseasonalize a data set, we've got to first find the individual seasonal indices for every data point. And then we've got to calculate the average seasonal index for each season. So that's how to do that here, which we talked about before. Now these values are really important. They're going to help us to deseasonalize the data set. So to deseasonalize the data set, we've got to do, so the deseasonalized value is equal to the actual figure divided by the seasonal index that we worked out in part 2. So just to reiterate, deseasonalizing data, the point of it is it removes the impact of seasonality, and hence it smooths out a data set.